Okay, the last thing that we need to know about polynomials to tie all of this together is something called end behavior. And end behavior, not just for polynomials, but for anything, asks what happens as x gets very large. This tells you what the ends of the graph do. So things may be happening in the middle, but what do the ends do? How do we go on forever and ever? Well, for a polynomial, we have that for very large values of x, either positive or negative, a polynomial of degree n will look like its power function, a n x to the n. So what happens is when you're looking at any polynomial, when x gets really big, what happens is you're really just looking at the first term of the polynomial. So let's look at an example and see how this works. So we've got 2x to the fourth minus 4x cubed plus 5. All right, so in the middle of the graph, this doesn't really tell us anything, but when x gets really big, we're talking about like 10, 100,000, million, what happens? Well, when we're plugging in really big values of x, is this 5 going to do much to the graph? No, like basically rounding-wise, it's gone. And when we're plugging in big numbers like 1,000, this number is much, much bigger than this number because it's got a bigger exponent. So that's why we say for very large values of x, this is the one that starts to dominate. This is the one that's changing the numbers, and these numbers down here aren't really doing as much as x gets really, really big. So what happens is when x gets really big, it's going to look, this graph looks like 2x to the fourth. That's a power function. We know how to graph that. We know that it's a parabola, and since the leading coefficient is positive, it's a parabola up. Okay, so on the ends, this just tells us what happens on the ends. We know that on the ends, it looks like a parabola up. So our two ends are going to be pointing up like that. Okay, let's say we have f of x equals 4x cubed minus 2x squared plus 1. Okay, same thing here. As x gets really, really big, these other terms don't matter as much. It's really just the 4x cubed that matters. So we know that it looks like x cubed on the ends. So our end behavior, okay, picture x cubed for the whole thing. It looks like this. Okay, so we know that it's going to point down on this side and up on that side. Okay, so we know that the ends have to look like this. Okay, so if it's even, it looks like a parabola. If it's odd, it looks like x cubed. All right, let's say that we have f of x is equal to negative 2x to the fourth plus x squared minus 3. Okay, so this is going to look like negative 2x to the fourth on the ends. So we know that x to the fourth, that's an even degree. So that's going to be like a parabola, and the negative out front is going to be like a parabola facing down. So this is like a parabola down. Okay, so when we draw that, our ends are going to be like the ends of a parabola facing down. So we're going to point down. So if it's even degree, it's going to look like a parabola, and if it's positive, it'll be facing up. If it's negative, it's facing down. So your even degrees will look something like this. We've got one. I'm going to have to erase this one, so remember what that was. And then our last possible combination, let's say we have negative x to the fifth plus x cubed plus 10. Okay, so what does this look like? Sorry, my handwriting got a little sloppy here. That's a 5 right there. Let's see if I can make it a better 5. Okay, so when x gets really, really big, we're looking at this leading term. So it's going to look like negative x to the fifth, and we know that x to the fifth looks like negative x cubed. Okay, so when we go to draw the ends of this, remember what x cubed looks like. It looks like this, and the negative out front is going to flip it just like it did for the parabola. So it's going to flip it across the x-axis. So we're going to point up there and down there. Remember I said it was important to remember that negative is going to be a reflection, so this is where it comes into play. So it's going to flip it. This is our x cubed end behavior. This is our negative x cubed end behavior. Okay, so that gives us our 4 possible possibilities. We've got odd and even, positive and negative, and those are the 4 end behaviors that we're going to have.